Yeah, we slanted to the left, but it's fine.
Slanted.
Let's get started.
Why is it slanted to the left?
They forgot to put my name on there, but I did to help.
Yeah, you did.
Okay, C++ basics. So this is basically gonna be a continuation of what we did last time. Hopefully a bit more organized because we put in a PPT. And this will basically tell you most of the important stuff that you need for robotics coding, and then we'll start moving on to actual robotics coding, like with Vex. But yeah, this week we'll focus on this. So let's get started.
Okay, back to Hello World. I know we introduced this last time, but our introduction was garbage. So, yeah. Well, this is quite. You'll find commenting quite important. So a comment is just when you // You start a comment with // It's just basically notes that you write to yourself in your code, just so you know what certain things do.
So let's say you make like a for loop or a while loop, and you comment, this is for drive control. The people who read your code, who didn't actually code it, will understand by that comment that, oh, this is what you use to drive a robot. So commenting is really important for like interviews and stuff, where you just show off your code.
Yeah, the notebookers really want us to tell you guys to comment, because
Judges want.
Judges want comments.
Judges really want comments in your code so they can follow what's going on.
And then later on, we'll teach you some commenting standards and what good stuff you can put in comments that will make the judges like your notebook.
Yeah.
Moving on.
Yeah, hashtag include IOStream. We kind of went over this last time too. But yeah, it's just like, basically, it's just special sauce right there. You're just including like the standard C++ library. IOStream in this case is just for cout.
Yeah.
It's just certain functions you need to include certain C++ libraries that have the function to them.
And when you go into robotics code, you'll be including something called API.h, which is basically Vex's library for all the motors, encoders, IMUs, and all the stuff. So that will enable you to write robotics code. And that's like an example of a library. But
So what are some examples of functions?
functions?
Yeah.
Well, like
You're mentioning functions.
functions. They're not really functions. I just want to call them that. So yeah, like cout is technically
It is a function.
it's a function technically, yeah. But yeah, so cout is found in the IOStream library of C++. So you can't use cout unless you include IOStream, which you probably do that in Vex occasionally because you need to
debug.
Yeah, debug. So if your code's not running properly, you just need to cout some stuff. We'll get to that later though. So here you'll see using namespace std. Well, we're gonna kind of get to that later as well, but basically, something like cout is found in the std library. So if you didn't have using namespace std, you'd have to type std ::. cout. In Vex, a lot of the Vex commands are in the namespace Vex.
Which a lot of people include using namespace Vex to make it easier, so you don't have to do Vex : motor, blah blah blah. And it depends. It really depends on your preference and what kind of coding you're doing. If you're including a lot of libraries, because once you get into more advanced coding, there's like templates that are available to you. But once you start going into that, there's a lot of overlap between different, like there's multiple definitions of motor that someone might make. Like Vex might define a motor this way, while another program might define motors this way. So as you go into that, I wouldn't use a namespace and literally just type out whatever, : whatever. But that's for later. So yeah, a lot of laters in this one. And then there's int main, which is, like I explained later,
It's the main function.
it's the main function which the code will run. As I showed last time, the Vex also has an int main which runs, which then splits out into multiple branches of autonomous drive control and stuff.
Control, yeah.
So,
Yeah, and then cout just prints whatever's in there to the terminal.
yeah.
And yeah, so when you're writing a function, you always want, like with int main, we'll get to this later too, but you want to usually include, you want to always have brackets. I tend to start my bracket after the main because it's just more size.
Yeah. Doesn't matter. Same thing.
Same thing, yeah, accurate.
Okay.
Okay, yeah, I'm just saying this is the same thing, but yeah, certain functions like cout reside in hashtag in the include libraries. Yeah, IOStream has cout, but yeah, so include that IOStream, yeah.
And then endl's basically, it's like a new line, a new character. So if you put an endl, it's gonna start a new line. So when you, last time we said if you just see out without putting slash n or endo, it's just gonna print continuously in one line, right? But endo will just make a new line.
Okay, this is big, okay? This is C++. Yep. You need semicolons after every line. Every line of code, you put a semicolon at the end.
With a few exceptions.
There's a few exceptions, but you don't worry about that right now. That's like way
Is
later.
it gonna hurt to put semicolon?
No, it'll tell
Yeah,
you.
actually-
It'll tell you when you're wrong. So.
Yeah, so when you write a code, the compiler will basically tell you, oh, you forgot a semicolon, or you put something. So if there's an error in your code, your compiler will tell you. And they're usually very
They're pretty good.
telling for a semicolon error because it says just missing semicolon. But for other errors, it's not going to be that telling, which then you might need to search it up on Stack Overflow or ask us. I guess.
Semicolon. End of every line. Okay, so I took the liberty of writing some C out stuff. It's pretty standard. Can you see it? You can read it? Okay. Well, okay. So first, let's start with endl versus new line. So right here, we're doing hello world again. Also, before I forget, here, the thing I was mentioning earlier, the using namespaces STD.
Hello. Yeah, most of the teams are not here, so
Oh, okay, all right. You guys learn a lot.
Got 3 people now.
yeah, amazing.
Video camera.
Yeah. Okay, yeah, so here, I didn't include using namespaces STD, which means I have to type STD : before every cout, every endl. Yeah, it's a bit of a hassle, but yeah.
Okay, let's see.
We'll start now with the cout.
So, what do you think this 2 lines will print? Anything else?
What does a double colon mean?
Double colon?
Oh,
So it's just basically calling the namespace of STD, which includes,
the cout function.
oops,
It's a comment.
huh?
Start a
Like-
comment.
Oh, these?
No, like the double colon.
Oh,
Yeah,
columns.
Yeah, so basically, cout is part of the namespace in library called IOStream and standard. And basically, if you don't include this, the code won't know what cout is. Because cout, you can even define a function called cout, right, inside your code. So what this does is, it specifies what namespace you're calling the cout from. So you're calling it from the standard namespace, which will tell you, oh, this has a definition of print something, which will print it out. So it's basically specifying what cout is from what library.
Yeah, the
Where's
standard.
it gonna print it?
Oh, it's gonna print in your output terminal. So,
Vex has that as well.
can anyone guess what this will print?
Lower?
Anyone?
Hello world and hello world after that.
Yeah. And then another line after that, but that will be blanks.
Okay, wait, before Steve goes too fast. Okay, these are two, they basically do the same thing, okay? No, this is important, okay? This is endl, and this is new line. Steve prefers new line, but I disagree, okay? They both do the same thing, they move on to the next line in your cout, but endl is just a little easier,
Right.
It was a little easier to write, a little faster to type, but realistically you can use either, they both do the same thing.
So this will basically print hello line, new line, hello world, new line, hello world, and then a new line. But there won't be anything in the new line because you didn't put anything after it. And then this. What do you think this will print? Yeah.
So would it be like hello, and then because you didn't like go to a new line world, so like just hello world?
Yeah, hello world, like stuck together between not any spaces, right?
Yeah.
Hello world stuck together, and this will print new line. And then, what about this?
Wouldn't it be like hello then like just world?
Yeah, it's the same thing as this one. It's just that we put it in one line by adding another one of these.
Yeah, so the thing about cout is you don't have to just stick to one output for every single line of cout. You can kind of change stuff. So you see these two double arrows going into cout. So if you put a double arrow and then have it print one thing, then you can put another double arrow and have another thing print as well.
So you can just make it forever. But not a lot of people do that. So.
Yeah, I like segmentation. Realistically.
What about
But
this?
either works.
These 3 lines. What would this print?
Hello world and one line.
Well, more than one line. Same thing. 3 in a row. So basically, you can just print a variable into this, which is also very useful in vex coding. So let's say you're trying to debug how much the robot went, right? You can print. You can make a variable called motor position, and then print out the variable later in the code to debug.
Okay, that's an alphanumeric one.
Huh?
Alphanumeric is a string.
Yeah. And then.
Okay, yeah, no. So I was just saying like some like personally what I like to do. So like if I'm trying to print like A, B, C in the terminal, and then moving on to the next line printing D, E, F, I like to chain my C out so it does like C out and then double arrow and then A, double arrow B, double arrow C, and then moving on to the next line and then making another line. But that's just personal preference. But I think it's easier to think about it that way realistically.
So this will print hello world, I like blue, and then hello world. Because the variable is still the color sitting on top.
Yeah, that's what it printed. I feel like you can kind of see what the problem is. There's a lack of spaces. Yeah, so that's another thing about C out. Yeah, so if you see out something in like without a new line, like if you see out two different things, there won't be a space in between. It'll just print it continuously. So in order to put a space, you can just put another string that has one space in it.
Yeah. And it will just print blank space.
Yeah, it'll just print a blank space.
Okay.
Okay, so Steve, what's that?
Yeah. So if you have do you have your laptop with you?
No.
Do you have your laptop with you? We should have told you to bring one. Oh, can we borrow yours?
Yeah.
Yeah. You guys can work together if you guys
Steve,
want.
Steve.
Oh yeah, I have mine too. Actually, yeah.
Fantastic. 3 laptops. for 3 people.
Hooray. Wow, that's
Yeah.
quite coincidental.
So go onto a site called Online GDP. You can search it up on websites and you'll get it.
This is a message from Albert.
Okay,
This is a message from Albert.
Yes.
Something about
It's basically the same thing. So try to get this code to print that.
wait,
Where do they have to be?
yeah, where?
Huh?
This is the one.
What IDE?
Oh, Online GDB. Just search it up on Chrome or Safari or whatever, and it will come up the first thing. And it should be in C++ that instant you log in.
Oh, it's C++.
Yes. So try to print that.
Oh.
Is it C++?
Yeah, I'll use those other solutions. Yes, you want to go to
Choose C++. Yep. And try to get that. Go back.
Let's close compile.
Okay, go back
Yes,
to the
sir.
screen. Try to get that to print. It's fine if you don't get it, but
Try your best.
try your best. You have, I don't know.
Yeah, also to run your code, just push run. It really tests it.
Yeah, you want him to write the code to feel.
Yeah. So try to print it.
I know you just got here.
Yeah, just try to get that as an output. I am part of CK Robotics, new line. Sunday Club Photo, new line. You should probably show up.
Sort of the way they did homework.
Yeah. Moving on. Yeah, they all got it. Great job.
Fantastic.
Your first C++ program.
Yeah, that's what I
The
did.
solution, you can use ando instead of /n. Same thing.
I used to go at the end because I wanted to.
Okay, now
Yeah.
data types. Okay.
You can go.
So you guys all know what a variable is, right? Whether you learn Python, Java, which I don't think you guys learned, and then C++ or Scratch. So basically, these are data types for the variable. So let's say we want to have a variable A. Let's say we want the variable to be a number, like 1, 2, 3, -1. It will be considered an integer variable. So you would declare it by int, my integer, or if you want the variable name to be A, int A equals 5. And it will make a new variable called A, or my integer in this case, that has the value of 5. And that's how you declare.
Yeah, so also an integer is just a whole number. Any whole number, it could be negative or positive, -5, -2, 1, 5, 10,000. Just a whole number, no decimals. That's an important thing to know about int.
So feel free to like on the compiler, on the coding thing, just declare it like that and try printing it or whatever you want. And it will help you more learn better. Now this is a double. A double is basically an integer, but you can have decimal numbers, and it is a bit bigger, right?
Yeah, so it's a floating point value. A double and a float are very similar. They're basically the same, honestly, for all intents and purposes for basic coding. The difference is double can hold a little more data, but honestly it shouldn't matter. So float and double are both, you can just have decimals. They can be negative or positive again, but yeah, just a decimal number.
So by what we mean by more data, I mean it's like if you variable is stored in something called a memory in a computer. Now that's not really important because we're not going to directly touch memory until we go into later lessons. But the problem is these all have a preset amount of memory allocated, like 8 bytes or 16 bytes. The problem is those can only hold up to a certain amount of number before it breaks because it's way too much.
Yeah, so for float, it's approximately 67 digits.
Oh,
and for
double is
decimal, it's around 15.
So in robotics, I would recommend you use double just because it's a decimal. A lot of values in robotics are decimal, and just because it's big, so you don't have to worry about it being too small for it to store.
Yeah, one thing to note about doubles and floats though, is that if you're trying to compare, like if you're trying to compare a double to something, a double is not an exact number, so it could have a bunch of like garbage at the end, so like 0, 0, 1, 3, 5. So I would never try and like say a double, so like if I had double A, let me just do it.
Okay, so basically, you know how a computer works, right? They have their binary system, right? So you can 0 or 1.
That's a stupid way to explain that.
Okay.
Okay, no, so what I'm just trying to say is if I have double A equals like some 5, whatever.
Wait, yeah.
What does return 0 do?
Oh yeah, so in main, this is the main function.
It's an integer function,
It's
right?
an integer function, so it always has to return an integer.
Okay, so
As default.
we'll teach you more about a return in functions. They usually don't matter. No, they actually do matter. Okay, if you're not doing something specific with it, you don't have to write it, because it will. Okay, so what? Sorry. A function. You know what a function is, right? In C++, when you exit a function, it returns something that's dependent. So if it's an int, it will return an int number that you specify at the end of the thing. So if it's a string function like string A, at the end of the function you will return a string, and it will return a string that will push it back to the function that you called, right? So let's say, okay, it's not okay. This isn't important right now. You don't have to worry about it. Even if you remove this from this code, it will not change it anyway.
Okay.
And then we'll teach you more about it when we go into functions, which will probably be next week. Yeah.
Okay, this is what I was trying to say. So with a double, just one disclaimer, if you have like a value like that, 5/3, the value in the double won't actually be 5/3 because it only has a set amount of precision. So don't do what I just did there. If double is equal to whatever that, you can do less than or greater than, but just don't do that. Please don't do that. Because it most likely won't work.
Do you guys understand? Okay, yeah.
Because this only has a set amount of precision, and that number is like 1.66666 something, but it'll be not that in the double.
So basically, just the one for double. Mostly in robotics, you won't be checking if some value is equal to another. Mostly you'll be using greater or less than, because it's robotics, right? It's real life. There's nothing that's equal to each other completely, so you usually don't have to worry about it. There's something called character, which is basically one letter, but that letter can be anything from alphabet to a number to a space to a null variable, which is basically it doesn't exist. It's kind of ironic, but yeah. So it's basically any character. So if you search up something called an ASCII chart, it will show you all the characters that is possible to be ASCII chart right here. ASCII. It will show you any character that you can use in your coding. Can you make it full screen? Yeah, okay. So basically, everything that you can type is a character in the computer, including emojis. But you don't use emojis in coding, so these. Not a lot of people use these ones because they're usually not used a lot. There's null, which basically nothing is inside that character. There's numbers, which is these. There's letters. There's percentage, money, space. They all have an ASCII value assigned to it, which you can use to.
Honestly, you won't use characters.
You won't use that. You won't use characters.
If I'm being honest, the most important things in robotics is integer, double, and float maybe, but they're basically the same thing. And Boolean, yeah. So the other character, string, and unsigned integers occasionally are useful, but mostly won't be.
Okay, so character is that, and string is just a jumble of characters in one variable. So, hello world, that's a string. my name is string. And the funny thing about string is that it doesn't have to be letters, right? Because a character isn't just letters, right? It's numbers and like equal signs
White
and everything,
space.
right? White space too. So hello, a string can actually be 1. 1 can be a string. The value 1 can be a string. It won't hold an integer value called 1. And if you print it out, it will print out the same 1. So if you want to show them.
Yeah,
A
so
string.
I can just create string. Trigger
1.
space. There we go.
Now if you print,
Just one for that. Okay, now.
I'll just print it normally. So we'll just print 1.
Oh,
Oh
my
my
bad.
god.
My bad. Oh yeah, so a special thing about string, it's actually not a data type that's just like there with C++. It's in the STD library again. So you have to put the STD identifier,
Yeah, just run it.
same standout.
And I'll print.
1 space space 1 and.
Yeah.
So
You won't be using string a lot in robotics. So don't really worry about it. Now Boolean. This is one of the more important ones in robotics. It's basically true or false. Yeah, that's basically it. It either holds, it's a variable that either holds true or false in it.
Yeah, so also true is assigned a value of 1 and false is assigned a value of 0. So when you print it, when you print a boolean that's true, it will print 1, and if you print it boolean that's false, it will print 0.
Now this is important when you get into for loops, while loops, and if statements, which we'll cover down the slides.
Yeah.
And there's many things you can do with Boolean, such as if you put an exclamation mark in front of the Boolean, it will swap the status. So let's say we have a variable called A, Boolean variable called A, so Boolean. Let's set it to false. False.
Oh,
Now if you print out the not A, so if you put an exclamation mark on it, it does work, right?
it should work.
And then put an endo. This will print out true. So what this does is basically flips the Boolean variable to the other one. So if it's true, it flips it to false. And if it's false, it flips it to true. And
Yeah,
it's
so
just
if
one.
you can see it's just 1, yeah, that's true.
And that's important for robotics coding. Yeah, you'll see general cases later as we teach you guys useful robotics coding. And then there's unsigned integer, which is
You might not find that as useful, but it's just an integer that doesn't have any negative values.
just positive numbers.
It's
or
just positive numbers.
natural numbers. Yeah. Moving on.
If else statements.
This is where actual robotics coding is relevant. So you will be using if statements and else statements a lot in robotics coding, like we showed you with Scratch, right? Block code. We showed you how to use these if statements, and we'll get into more detail right now. So.
Yeah, so this is, I mean, if statement's basically the same between any coding language, slightly different syntax. So these are all valid if statements, but personally, I would recommend the third one. As you can see from my little note there, examples 1 and 2 technically work, but as you can see, they have no curly brackets around the statements. But yeah, we recommend using the brackets because there's a few reasons why you should use it, but one of them is like that it really makes your code easier to read, and it kind of prevents mistakes, because if you don't have the curly brackets and you like decide to write more or something,
Like 10 if statements.
yeah, 10 if
They
statements.
get mixed up a lot.
Yeah, and if you want to I'll explain the else thing later, but yeah.
So did any of you do Python? Right? You guys know that you don't put brackets in statements? Yeah, so I don't
You guys
recommend
use
that.
Tabs with this space.
You put a tab before your statements, right?
Yeah, yeah. So basically in C++, just put the brackets.
Okay, so we'll make an if statement in front of you. Okay, what do we want to check? What do we want to compare? Any ideas, any suggestions?
2 equals 1.
It can be random. Okay, we'll compare two integers. Int A will be 1. Int B will be
Nice.
3. Let's say we want to check if A is bigger than B. We'll put an if statement down. We put a bracket. Oh no, a parentheses to start the Boolean expression. And we'll see if A is bigger than B. And we put a curly bracket down, tab down, and we'll make it like this. We'll make it cout true. And then if it's false,
That else.
because it's either true or false, right? So we'll put a state with that.
Yeah, so basically what you're doing is, if the thing in there is true, it'll run this line of code. Otherwise, if it's not true, it'll run the next line of code. Yeah.
So is 1 bigger than 3?
That's
No,
probably
it's not. So it will show out false.
What does the stuff behind the int do, like the int ARPC?
Oh, that, okay.
That's garbage, yeah, don't worry about that.
Okay, so this is something called a okay, yeah.
Don't worry
It
about
doesn't
it.
matter.
Don't worry, yeah.
There's a lot of stuff that we are using that doesn't matter in robotics coding and in basic C++ writing. We probably shouldn't have put that, so I'm sorry if it confused you, but yeah.
No, it just
It doesn't matter.
Yeah.
It serves zero purpose. It doesn't change how your code runs. Yeah.
It was just default.
So basically, let's explain that again. If statement, this is a Boolean expression, which will check is A bigger than B. If it's true, it's gonna run the first one. If it's false, it's gonna run the second one. Because it's an else, right?
I think we can establish that one's not bigger than 3.
Yeah.
So it ran the false state.
Many complaints about that? Okay, now there's something called else if. Yeah, else if. Now, I think in Python it's called elif, right?
Yes.
Yeah. So basically, it's another if statement that is inside a whole if statement. Now, just write it out. So it's basically the same thing as an if statement, but
Here,
equal.
there we go.
Okay. And then write else. Now what this does is, if this is false, it will move down to else if. And if this is false, it will move down to the else. So it's basically, an if statement, it goes down in order. So let's say the first one is false. Oh, it's false. We'll move on to the second else statement. If that is false, we'll move on to the else. Okay, now we'll run it, and then just change the A to 3. Okay, now this will be false because 1 is not equal to 3, but now if it goes to 1 and 1, it will print out maybe. Because it failed this, but it passed this, right? Because 1 is equal to 1, so it printed out maybe. Now in the if statement, if something works, it won't move on to the second one and just exit the if statement. There's something called a switch.
Don't worry about that yet. Okay, so one thing that you need to know about if statements is that it goes, there's a bit of a hierarchy. It goes down the line. So so it starts with if, and then if you have a bunch of else ifs, it just keeps going down until it finds one that's true, and then it does whatever's in the statement of the true one, and then it just moves on. It doesn't go through the rest of the if statement.
And then if nothing above is true, it just runs the else statement.
Yeah, so like if I just typed another else if, and then said like, I don't know,
A is listen.
A is greater than 0, sure. A is greater than 0, and then I wanted like, I don't know, SDU.
Yes.
Fantastic. Yeah, so now we can establish that both of these are true, right? So when it runs the code, it will only print the maybe, and it won't move on to the fantastic, because it already ended this line of if else.
So if you want to check for that too, you will make another if loop that just starts with a normal if, and then just make another one. Yeah. And this is the comparison operators which you will use inside your Boolean expression inside the if loop. So this is the same thing as Python and Scratch. It doesn't change.
Yeah, they're pretty like intuitive, standard stuff, like less than, or equal to, greater than, equal to. The two that you should probably note is that exclamation equals is not equal to, and one thing, never type just one equal sign if you're trying to ask, like in an if statement, if you're trying to compare if like A is equal to B, because yeah, when you're trying to check if one value is equal to another in C++, you have to use the equals equals operator, not the equals, because just using one equals is used for setting a value to another value. So like if you want to set a equal to 3, you just use one equals. But in an if statement, you have to use equals equals. If you want to check if something, one variable is equal to another.
And a lot of people make that mistake, so don't worry about it.
It also tells you usually
Yeah.
if you do that.
It says, oh, you're assigning a value. Did you mean equal equals?
Yeah.
The compiler will be very friendly about it.
And
It will
usually-
not yell at you. Okay, what is the output of this code? Ignore the missing main and include the IO stream.
But yeah, if this was an if, then what was this code
I
output?
forgot the brackets.
What?
You forgot the brackets.
Right. No, that's the point.
Oh yeah, that was print. And then yeah,
Anybody?
X is less than or equals 5.
any other guesses on what the answer is?
Section 4. Let me explain
Wait,
why.
what?
Okay, no,
Okay.
go back.
What?
He's trying to guess.
Okay.
What? Okay.
Yes.
Okay, what would be that?
If. Okay, so. Split it. Wait, x and y are greater than 5. X is greater than
Any
Wait. Wait, so x. Okay, so if x is greater
So X is 1 right now.
than. Right.
I don't think 1's greater than 5 last time I checked.
Yeah, it's not.
Yeah, okay.
It print either.
The main question problem is, this is wrong, right?
Yes.
Do you think it passes on to this? Because this it fails,
No,
right?
'cause it goes.
Yeah,
Wait,
no,
What is
because it
when it
was-
changes the other if or. Well, no, like.
No, because
no,
the
if it's
if's
wrong.
in the other if.
Right. Yeah. So if it's wrong, it just goes to the else.
So you think it will print out this?
That's what a Python user would say. It won't do that, okay? In C++, white space does not matter. Tabs will not do you any good. It's all about the brackets, okay? So there's no brackets as you can see from all these if statements. So you get the problem where you get the dangling else. So basically, even though that this else was on the same like plane as the other one in the previous example, you see it's on the same spacing. C++ doesn't care about that. There's no concept of spacing in C++. So this will just default to the else of the preceding if statement. Yeah, so it's just the else of this if statement, so technically nothing will happen. If you want to fix that,
Use curly brackets.
use curly brackets, okay? You put these curly brackets here. This is why I tell you to always use curly brackets in if-else statements. So since that you have these curly brackets, the else that's on the same like plane of existence as these curly brackets will be assigned to this if statement, not that one. Because that one's inside the curly brackets.
And we should also put curly brackets inside here. But
yeah, I would put curly brackets in.
just put curly brackets.
Yeah.
Don't imitate Python users.
Yeah. Moral of the story, use curly brackets.
Find error in this program. No curly brackets, but it should be fine this time. Still should have put curly brackets.
Yeah, should have put curly brackets.
Anyone have a guess on what's wrong?
There's no
That's
like,
also no curly brackets.
It still runs,
Yeah.
okay?
So, actually, we're just gonna assume this is inside an int main function.
Yeah, no idea?
I don't see any like, is like sin like an integer?
Oh, don't worry about
Okay,
this.
since so stdcout, right? We saw that before.
Yeah, so
since
out-
basically an input, so it basically takes an input and puts it into the variable code rating.
Oh.
So that's not an error. Any ideas?
Oh, it's not equals equals to.
Yes, you're
Exactly.
right. It's not equals equals. A very common mistake that a lot of people make.
Always use equals equals when you're trying to compare two different values, not just one equals.
Equals is just for assigning.
Yeah, just for assigning like a to 5A. Okay, let's talk about and.
I mean, a lot of you, all of you learn text code, so you guys know what and is, right? Yeah. So,
Yeah.
okay, so basically, we if we want to have a if statement that checks for two things at the same time, we use an and statement. So if this is true and this is true, it's gonna pass. But if this is true and the other one's false, it's not gonna pass. It's in the and statement. You guys supposedly know it.
Yeah.
We'll just show
So
an example.
if A is greater than B,
Just write
and then
and.
double ampersand.
Just write and.
No,
Okay.
you can't just write and. I won't allow it. And A is equal to B, sure, then.
This will
Okay,
be.
yeah, so now it'll check if this is true, this statement is true, and if this statement is true. And I made the classic mistake after talking about it for so long. Yeah, so it'll check if either of these statements are true, if both of these statements are true, sorry, and then if they both are, then it'll run whatever's in there. So yeah, that's the AND operator. Okay, now talk about OR. Okay. Just, I mean, it's very similar to the syntax of the AND operator, except it's, I don't know if you know what the two vertical
Oh,
lines.
like absolute value?
I mean, sure, they kind of are, but not encoding. Encoding the double vertical bar
It's an or.
is OR, yeah. So it's basically, it's very similar to AND, except instead of checking if both of these are true, if either of these statements are true, it'll run whatever's in there.
Okay, now they made it the proper way, but technically,
Don't-
instead of writing, you can write or. You can just write or and
but
end in letters.
I disagree. Don't ever do that.
Okay, I don't recommend it
Yeah.
because it's just better to use the logical operators
Because
and then the.
the only reason OR works is because this is a newer IDE. I think if you went back to like 2015 or something
It
and
didn't
you
work.
tried to put the OR, it wouldn't work. So you need. I'd recommend just using the double vertical bars.
That's or and
That'll
double
always work.
double and is
Yeah, and double ampersand is AND.
okay. Basic stuff.
Yeah.
Same for Python.
You don't need that.
Oh, one problem. The Python you can do if A equals B and B equals C and C equals D. That works, right? In C++ you can't just list logical operators like that. Oh, with logical operators. you can. Okay, never mind.
Yeah, don't listen to him.
Yeah.
He's wrong. Yeah, so
Never
I
mind.
can keep chaining these. I can just say if and if.
But if you use and, like the letter and, you can't do it. So that's why we also recommend that double hemisphere.
Greater than or equal to. There you go. Yeah, so I can just keep chaining these as long as I want. So yeah, I'm doing ends. Okay. Next switch statement. Honestly, I just put this in there because it's a thing. You definitely probably won't use it very much. It's just kind of a more compact way to write like a list of if else statements. So Steve, if you want to explain the switch. You don't know how a switch
No, I
statement
do know how it works, but like.
You don't want to explain it. Okay.
Okay.
This is switch lightnings, like they have in Lego.
It's basically an if statement,
Right,
but
it's like an if then statement.
yeah. So it's like you know how a switch works, right? If you have like 3 levels, you can click one, you can push down to the other one, you can push down to the other one, it'll select what thing you pressed.
Okay, yeah, so the way the switch statement works is, so here you have vehicle class. Let's say I give vehicle class a value of 3. Sure, 3. You have to have int in there, by the way. So if I give vehicle class a value of 3, it'll look for case 3, as you can see there, and it'll do whatever's in there. But one thing to know about switch statements is that if you don't have this break here, it'll just move on to the next case until it finds a break, whatever the statements in the next case is. Honestly, you probably won't use them.
I don't
That's why we're
recommend
not.
them.
Yeah, we're not going over them very.
I never used them. It won't be useful.
I mean, it's useful if you're like doing.
Like
some
if you have like
stuff.
2,000 if statements.
but yeah.
But no one does that. So.
That's psychopath.
Okay, reading problem 1.
Oh.
Of course.
If x equals -2, y equals 5, and z equals 0, and t equals -4,
Okay.
what is the value of each?
False logical expressions. So just
True or false?
yeah, true or false? Are these true or are they false?
You can do them in your brain. You don't have to write
Yeah.
the code out.
I think we can. Yeah.
Yeah. Okay.
A is false.
Is A false?
Is A false? Probably.
Yeah, it is false. Okay.
It is false.
What about B?
True.
True?
Yeah.
It's true.
I don't know if you saw that, but yeah.
C. There's an and in there.
3 times 5 is
3
15.
times 5 is 15.
Just remember, these are two separate Boolean expressions, so both of them have to be true for this statement to be true.
Yeah. 3 times 15. Wouldn't C be false?
Let's see, false.
Yeah.
This is 15 divided 4. That's 4,
What?
which is smaller than 8. That's false.
Exactly.
But y is bigger than 4, so that's true. But it's false and true. And it's in an end statement, so this will be false. What about this? True.
False.
False. D?
3
Yeah,
times
D.
5.
Z is not great. Oh, Z is less than 2. True, true.
True.
True. That would be negative 4. Negative 4 is less than 5, right? That would be false. Z is 0, which is less than 2, so that would be true. But this is an or statement. So either one has to be true, right?
Yeah.
Because this is true, it's gonna give out a true statement.
Wouldn't C be true?
C
Yeah,
will
C
be
is definitely true.
no. Oh wait, it's less than.
Yeah, yeah.
Yes, C is true actually.
Oh.
Sorry. Because 3 times 4 divided by 4 is 4. Something 4 something something, which is less than 8. And y is 5, so it's greater than 4. So both of them are true, so it will be true. Sorry. What about E?
True.
True. True. Okay.
Yeah,
Ah.
that's right.
Only one false. While loops. Now this is one of the more important stuff for robotics, because you will be using loops a lot in robotics because you can't just write everything, right? You can't just write 2,000 lines of the same thing. So loops are basically something that just continuously just does itself again
Until for a certain
for a
under
certain condition. So it depends on if it's a while loop or a for loop. Now we'll start with a while loop because it's a bit more simple. This is a while loop. Wait, yeah, it is. This is a while loop. So how a while loop works is basically it's a while with a test condition. This is a Boolean expression. So while this inside is true, this will run.
So yeah, continuously run.
It will continuously run until this condition becomes false. Now let's start with int count is 1. And then we'll put it inside a while loop. Count is less than 10, right? So this is true, so we'll run this statement. It will see out, hello there, then I'll add count. It will add 1 to count. Now count is 2, right? 2 is still less than 10. So we'll run this again until you continuously loop until you reach count is 11, right? If
No,
it,
wouldn't it be like count 10? Because like it's less than or equal to?
yeah,
Yeah,
so
it's less than or equal to.
10
so-
is less than or equal to 10 because 10 is equal to 10, right? So that would be true, so we'll run again. But then after count becomes 11, this is gonna be false, right? So it won't run this while statement. So it's basically, if you don't know how long you want your while loop to run, and you only know like what condition requires it to stop, like let's say the motor hits 500 centimeters, that's when you'll use a while loop because you won't know how much your motor, you won't know how long it's gonna take for the motor to reach 500 centimeters until it actually reaches 500 centimeters, right? So in this case, you would do like while position equals position
Is less than
is less than 500. It's gonna continuously run until position becomes 500, then it'll stop running. Good.
Yeah.
We'll write a code for a while loop. Okay, while loops.
Are we supposed to be able to read this?
Hmm?
Are we supposed to be able to read this?
Is it small?
Yeah, it's pretty well.
Thank you.
What should we set it as? While
Int is less. Int is less than. A equals 0, yeah. And then
okay. Why is it? Huh? Oh yeah. That's fine.
okay. Just write something. A plus plus. Yeah.
And then the code we showed with this, right? So basically it's just saying that A is the original A value plus 1.
So it's adding 1 to A, yeah.
Now there's a more simpler way to write it, which is A plus plus. It's the same thing as this one.
Yeah, they mean the same thing, it's just adding 1 to A. It's 1 to itself.
So we'll run this.
And it's probably printed it 20 times. Or 19 times. Yeah, 20 times.
No, 19. Oh yeah, 20 times. Because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, 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 to 20. And then that ran it 20 times. And then, oops, A is over 20. A is 20 at the 20th interval, right? Then it won't run because A hit 20 and 20 is not smaller than 20.
Yeah.
Hopefully.
So in Vex, you might have seen a while loop that looks like this. That's just like in op control, in your operator control.
Driver control.
Yeah, driver control. You need a while loop that has just true as its conditions, because you just need to constantly be running and checking what your state
Yeah,
conditions are or something.
True will always equal true, right?
Yeah.
So this will continuously run until you stop the code.
Or if you put like a boolean, or sorry, if you put this like b and I create a boolean variable called b, set that equal to false.
Not true.
Sure, true. And then I just like somewhere here,
Inside the
inside here I said
if A is like
I'm just gonna set it to false.
wait, that's not gonna run. No, it's only gonna run one time.
Yeah, it's gonna run one time. Because then so this is a boolean value that's true, and then it'll be set to b once it runs in this while loop. Usually you'll have like some if statement that once something happens, it'll set whatever is this while loop.
Like controller is on.
Yeah, like if you're pressing a certain button. But yeah, I mean we'll get more into that when we talk about Vex. So
Yeah. That's the while loop. Any questions? For loops. Now this is, I don't see a lot of use cases for for loops in robotics because unless you're doing autonomous and you're trying to repeat actions, but I still don't see a lot of it. Basically what it does is basically like a while loop. It's a loop, except that it runs for a set amount of time that you set. So what this does, and this is a for loop, we will make an integer value called I, that's set as 0, and this Boolean expression which is I less than 10. And then if it is less than 10, it will run the statement inside and then add 1 to I.
yeah, so
Put it outside of it.
yeah, so I would do I equals 0.
In time. In time.
Oh, you know that. Okay, yeah, so yeah, let me just explain how. So this for loop where I would say I equals 0. So I'm starting I'm initializing I with the value of 0, and then let's say like it'll run as long as I is less than 5. And then we're gonna say that I gets incremented by 1 every time it runs, so it increases by 1.
And now it doesn't have to be an I, it can be a J, it can be a, it can be a B, it can be like hello too. The variable name can be anything. It's literally you're just declaring a variable here. You just say print that, just print that, just print that.
Now, in robotics, where are you gonna be using this kind of thing?
Okay, yeah. So as I said before, usually this is a bit rarely used because in robotics you don't really have a time where you know how much something is gonna run. Like in autonomous, you don't really know how. Okay, like you don't know when the robot reached a certain condition until you know, right? That's where while loop is useful because you can check whether it reached or not and then just continuously run. I guess a for loop when it might be useful is like not really used. Okay. Let's say you're trying to make the robot spin 200 times. You would make a for loop that iterates from 0 to 200 and just make it spin 200 times. Now, there's probably more useful cases than that, but I can't really think of one straight out of my head.
Okay, yeah, so another thing is basically these two expressions, this for loop and this while loop is doing the same thing. It's starting, it's initializing its initial value A and I.
It's checking with
Yeah, and it's checking if it's less than 5 and then incrementing by 1 every time it runs whatever's inside. It's just that a for loop's a bit more simple way to do it. And yeah, I just do it.
Just print this and one. Yeah. Basically, same thing. It runs as 1, 2, 3, 4, 4. 1, 2, 3, 0, 1, 2, 3, 4.
This was the while loop,
And this is the for loop.
and this was the for loop.
That's awesome.
Yeah, mostly you'll use while loops in robotics.
And then next lesson we'll talk about functions, which is very useful for robotics because you don't want to type everything inside one like driver control. And then we'll start to get into robotics, like actual robotics coding, and we'll show you example codes, what to do when you need to like driver control autonomous, or how to track the motor's position and stuff.
And then we'll give you a template.
Thank you.
Thank you.
Thank you.